All right, so now we're finding all the points on the graph where f of x, on the graph of f of x equals the cube root of x squared minus 1 squared, for which f prime of x equals 0, and for those in which f prime of x does not exist. So here's what we got then. We're going to do, well, we're going to rewrite it. We definitely want to rewrite it so we can see it easier. And so we don't have to use the chain rule twice. Because what is this in reality? This is just like you have to know your rules of exponents and your rules of square roots and whatnot. This is x squared minus 1 to the 2/3. You can see it's squared, but then it's the cube root. So that's x squared minus 1 to the 2/3. So when we want to take the derivative of it, we're just going to use the power rule. So we're going to say, bring the power to the front, keep the inside the same, subtract the power by 1, but then we have to multiply by the derivative of the inside, which is 2x. So then what is our function here then? We have our top is just going to be 4x. Our bottom is going to be 3 times the cube root of x squared minus 1. Okay. So what is this graph? This is going to be something like this, isn't it? That's kind of interesting. I'll have to look at this graph afterwards. So that's our derivative. So what do we want to know? When is the derivative equal to 0 and when does the derivative not exist? Well, so, I mean, that's just really kind of a top and bottom equals 0, because when the top equals 0, that's going to be when the derivative is equal to 0. So whenever 4x equals 0, so that's when x equals 0, the derivative is equal to 0. And then whenever it's undefined, that's the bottom. And so I was thinking a little bit, if this was the square root, we'd have like a big range where this is undefined. But since it's the cube root, we don't. We just have when it's equal to 0. So whenever the cube root of x squared minus 1 is equal to 0, that's when this is undefined. And so that's pretty easy. You're just going to cube root both sides and add 1. So x squared equals 1. Square root both sides. X is plus or minus 1. So that's where we have an undefined derivative. And what I imagine that'll be in this case is a vertical tangent line. So I think the graph is going to look something like that. We've done the problem, but I'm curious. Let's look at this on Desmos, what this is going to look like. So, I mean, I'm just going to do it how we rewrote it. X squared minus 1 raised to the 2/3. Oh no. I was way off. So if it wasn't squared, I was thinking if it was negative, and if it wasn't squared, it would look like what I did. But that makes sense that, because yeah, the squared didn't really come into play a whole much, I guess. Yeah. So it would look like that if it wasn't for the squared, but since it's squared, that's making everything positive, and that's why it's flipping it like an absolute value. Okay. That makes sense. That makes sense. But either way, we did see. And see, so why is it undefined? It's not undefined because of the vertical tangent necessarily. It's also undefined because it's a cusp. But even if it wasn't for the cusp, it would still be undefined because of the vertical tangent.